Sorry, I'm late.
No, that's okay. Let me erase this. Wrote that all weird. All right, so I was saying I found some examples we can do for 9.9, and then we'll go to 9.10. So first example. So we're going to use a geometric series. Actually, let me write that down first. It helps out. So remember, geometric series, or I should say power series, is going to be f of x equal to 1 over 1 minus x, which is similar to how we had it before, a over 1 minus r, which is equal to a geometric series, right? And in this case, a is equal to 1, r is equal to x, which means you can change this f of x. F can be written as a series of x to the n. And remember that this converges when r is less than 1, and that is to say that x is less than 1 in this case, which means r would be 1, the radius. Okay, so it's an example, so let me show you what I mean. Find a power series for the function centered at h of x equal to 4 over 1 minus 7x, and c is equal to 0 for this case. Determine interval of convergence.
Four over 1 minus what x?
7x.
Thank you.
And our C is just, it's the center, right? That's what center.
Yeah, right. So a will be 4. R will be, lowercase r, is 7x. So remember, in order for this to converge, right, we said that the absolute value of r must be less than 1. So that means that the absolute value of 7x must be less than 1. And when you solve for this, you end up with a interval of convergence between -7th and 1/7.
Was negative 1/7?
And you divide the 7 everywhere. So the interval of convergence is -1/7 to 1/7, And r, capital radius, would be r equal to 1/7. So this would be like my scratch work over here.
So I'm assuming you divided everything by 7 to get the x to have a 1 in the front,
Yes, you divide all three sides.
like a regular inequality thingy.
Yeah,
Okay.
just like usual. So there's my interval, but once you have all this, you can technically rewrite this. So h of x equal to 4/1 minus 7x can be rewritten as the series representation of 4 times 7x to the n. So using the idea of geometric, you can change this function into a series. So that's the power series for this function. And there's the interval, the convergence, and the radius. Could I have any questions on this problem?
So the x in reality is x minus 0, or the x is because you got c, right? Oh, or I'm too far ahead.
Yeah, so the c would be 0, right? So it'd be x minus 0. That's true. Let's do one that's not 0, so you can see how that works. I'll probably need more space though. Yeah, I'll do it on a different page. Find a power series function centered at C and determine the interval of convergence. Right, so the homework is going to give you a function. And they'll tell you the center too. So basically you need to incorporate the center. So the C will be plugged in here. It'll be x minus C. So where we have the x, that's where that's going to go. And then we got to do some algebra to make it look like the geometric form, like we did before. So go ahead and multiply that out. We can end up with 3x minus 6 minus 5, which is, let's see here. It's not very pretty. Well, actually, let me just rewrite it. Because remember, I'm trying to get to something like this. I'll write the formula on top. All right. 1 minus. So I'm going to write the variable part second. And see what can I factor to make this prettier, right? Okay. So I need a 1 here, according to this. All right. So I'm going to divide every single term by -5. So I'm going to end up with 6 over -5 over -5 over -5 plus 3 over -5 times the x minus 2. So that will get me to, it's going to go ahead and, no, that's fine. -6 over 5 is on top. So now I have 1 minus 3/5 times x minus 2. So now that's in this form, a is -6/5, and r is going to be 3/5 times x minus 2. So once you have that, you can start setting it up in that form. Okay, so remember, so this means that f of x is equal to, so I'm going to skip or show the big picture here. Formula rewrote it into this, or algebra anyway. Which allows us to use the series formula, which would give us -6/5 times r, which is -3/5 times x minus 2 to the n. Because a, oh yeah, I wrote it right there, sorry. So I'm just applying the formula, this one here. Now let's do some algebra, because that looks kind of nasty, right? That would be equal to actually, sorry, there should not be a negative here. So we should have a 3/5 to the n times x minus 2 to the n. Which is the same, I mean, at this point we're done, but let's go an extra step here. We also write 3 to the n times x minus 2 to the n over 5 to the n. So this is the power series representation of f. So now we go back to the last few sections and decide, okay, where does this converge? Where does it diverge, right? And we know that geometric says it r must be less than 1. So you're going to take the r, absolute value, that must be less than 1. So then you remove the absolute value, solve for x, so multiplying by 5/3 everywhere, and that'll get us to here, right? Add 2 to both sides, that will be what?
Add 2?
Yeah.
Oh, you're doing that math. Okay.
Yeah, we're solving for x, don't forget. So this would be the interval of convergence. So interval of convergence is going to be 1/3 11/3. And then we have our series representation, and we have our interval. And the radius would be what? 5/3, yeah. I mean, technically I didn't ask that, but we should be able to find it.
We got the 1/3 is because we added 2, right? Okay.
Yes. Yeah, 2 to all 3 sides. So -5/3 plus 2, and 1 plus, and 5/3 plus 2 gives us this. Okay. Let's move on to 9/10.
Only question I have is,
Mhm.
we got the +2 is from right here, right? From the x minus 2, right? That's where we get
Yeah, yeah. Whenever they say the center at C or whatever, it's gonna be x minus. You're gonna plug in x minus whatever that is. So that's where this came from.
Alright.
And then after that, you're just trying to write it. Make it look like this. The geometric form.
Okay.
And once you get there, you apply the formula, which gives you the series.
Then we go back.
And then using the geometric idea, once you have R, you can answer these 2 questions as well.
Okay. All right. Thank you.
Yep. All right, 9.10. Taylor and Maclaurin. So theorem 9.22. So the form of a convergent power series sorry, that's the name of the theorem, I guess. Okay, so if F is represented by a power series which means f of x is equal to a sum of an times x minus c to the n for all x in the interval I containing c. Then a sub n is equal to f to the nth derivative of c over n factorial. And f of x is equal to f of c over 0 factorial plus the first derivative at c over 1 factorial times x minus c to the first. I think I'm going to write this elsewhere. This needs to be clear. Okay. Rewrite that. So when you expand f of x, it's going to be the 0 term with no derivatives, 0 derivatives, plus the first term with 1 derivative times x minus c to the first over 1 factorial plus 2 derivatives at c times x minus c to the second over 2 factorial all the way till f to the n at c times x minus c to the n over n factorial. Let me give you a definition of Taylor and Maclaurin series. So if a function, move this camera a bit. All right. If a function f has derivatives of all orders at x equals c, then the series zero to infinity of f to the nth derivative of c over n factorial times x minus c to the n is called the Taylor series for f at c. If c is equal to 0, then it is called the Maclaurin series for f.
And it's n equals 0 or n, is it a,
Yeah, it's n from 0 to infinity.
already think.
Okay. So basically it's the same formula. It's just that Maclaurin is centered at 0 and Taylor is centered at some general c. So what they're going to have you do is they're going to give you a function and you're going to have to take a bunch of derivatives and figure out what is the nth derivative, what's the pattern a sub n, and then build the power series that represents e or whatever sign or whatever they're talking about. So let's see here. Let's do this first one. find the Taylor series centered at C for the function f of x equals e to the negative 2x. C is equal to 0. So C being 0 makes it a little bit easier. Okay. So what you gotta do is take a bunch of derivatives and figure out what the pattern is, right? So here we go. So f is negative 2x. First derivative. What will be the first derivative?
Be e to the would be e to the x, would just be e.
Yeah, I mean it's gonna stay the same, right? That's what you're remembering, right? But there's that chain rule. So we're gonna end up with e to the negative 2x times negative 2, right?
Correct.
Remember? So we do it again. What are we gonna get?
E to
Second derivative.
Well, you take the second derivative. It's just
Same deal, right? But now you're gonna have two of them, right? Let me show the work. It'd be negative 2 again times negative 2.
the third would be negative e to the negative 2x times
So what is the pattern for the derivative, the nth derivative?
n to the negative. It's e to negative 2, and then it's gonna have negative 2 to the n raised to the n.
Mm-hmm.
By the time you get to the fifth one, it should go back to the original, right? Once we start multiplying it.
Yeah, should be. So if we use our formula, right, we just need the derivative pattern, which is going to be this piece. And then we have our power series. So oh, 1 second. I forgot one little step here before we do that. We got to plug into 0. F of 0 would be 1, right? F prime at 0 would be negative 2. F double prime of 0 would be 4. F triple prime of 0 would be negative 8. So now we can create the pattern for the Fn. So Fn at 0 would be negative 2 to the n, which is, or you could say negative 1 to the n times 2 to the n, if you want to have the alternating piece separately. So the formula says that f of x would be equal to f at c, right, over 0 factorial plus f prime at c over 1 factorial, right? So we would get
Wouldn't it be n factorial? Oh,
yeah, sorry, let me show the work. Sorry. So the pattern would be from n equals 0 to infinity. And the formula says you got to plug in the nth derivative at, in our case, 0 times x minus 0 to the n over n factorial. So we're going to have 1 times x minus 0 to the 0, 0 factorial, plus a negative 2 times x minus 2 to the 1 over 1 factorial, plus positive 4 times x minus 2 squared over 2 factorial, right? Plus a negative 8 times x minus 3 cubed over 3 factorial. So the power series represents this, right? Bring out space. I thought I could fit it in there, but I guess not. It's going to be 1 over 0 factorial minus 2x over 1 factorial plus 4x squared over 2 factorial plus well, technically minus, but that's fine. Right, once we get rid of that 0. And you see why this is 1, correct? No, this will be to the 0 power, so it'll be left with 1. So finally, we just write out the numbers, and we'll write out the power series, rather. So think of the pattern, as we said before. This would be negative 2 to the n times x to the n over n factorial. So this part takes care of the power, 0 power, first power, second power, third power. This takes care of the alternating signs and the powers of 2. So 0, 1, 2 cubed. So what they want is this guy representing e to the 2x. That's what this does. And that's what we're doing it. So basically, the main idea, right, in case you're still confused, is we're given a function and we want to find the Taylor expansion. So you expand it into a power series and you end up with this. So this is what we want right here. But in order to find the pattern, you have to take derivatives and then plug in the C that they're talking about and try to figure out, okay, what exactly is the series supposed to look like? Okay, so go over it one more time, because I know it's weird. First derivative, second, third. So you plug in the 0 and you find those values. So then you start to see the pattern. So then you go back and use the formula. We're using this formula here. And we try to write down the actual series. So plug in our C, plug in the values, and there we go. So the general form is going to be this here. So is there any questions about this? Okay, let's do another one. This time let's do sine centered at pi over 2, I guess. So I'm going to expand this guy. Find the Taylor series centered at C for the following function. So f of x is equal to sine x. C is equal to pi over 2. One second. So the way you start is taking the derivatives until you start to see a pattern. Oh, 1 second. Okay, sorry. All right, so first zero derivative means it's the normal function, right? First derivative means cosine, right? First derivative of sine is cosine. What is the second derivative?
Negative sine.
Should be negative sine. Third derivative
Cosine.
should be negative or positive?
It's gonna be positive.
The derivative of sine is cosine.
Oh, no, negative.
Yeah, so it doesn't change. But on the next one, the sign changes. What is the fourth derivative?
That would be positive.
Yeah, we're back to sine. Okay. But then it starts to repeat. So let's go ahead and plug in pi over 2, because that's where we're centered. So f of pi over 2 for sine, that's going to be a 1, right? First derivative at pi over 2, that will be 0. Second derivative at pi over 2, second, be negative 1. Third derivative would be 0 still. Okay. Fourth derivative will be equal to 1. And it looks like it's going to start to repeat. Let's write down a few more. Fifth derivative would be 0. 6 would be cosine should be negative 1. Seventh derivative. I'm only doing this so you can see the pattern, not because it's necessary. Oh, but what do you notice? About the pattern.
It starts off positive, and then go negative, and then positive, and then negative again. It's just 1 0 1 0 1 0 1 0.
Yeah.
Go down. That's it.
Now let's remember that and look at the formula. Formula for Taylor series says f is the nth derivative at c times x minus c to the n over n factorial. So let's go ahead and expand that. So the first one will be 1, right, when you plug in c. So that's this, the 0 derivative at pi over 2 is 1 times x minus pi over 2 at 0 over 0 factorial. Then the next one, that would be 0 times x minus pi over 2 to the first power over 1 factorial, right? Plus a negative 1 times x minus pi over 2 to the second over 2 factorial. Plus, go ahead and write it over here. Keep going. Plus, after negative 1, we got a 0, right? So 0 times x minus pi over 2 cubed over 3 factorial plus the fourth one is positive again, x minus pi over 2 times to the fourth over 4 factorial. So what do you notice? There's things that are going to 0, right? You see this? Which ones are going to 0?
For the, I think that's right.
Cosine. Cosine.
Or which terms, I guess? Like,
It
yeah,
would
it is the
be
cosine.
Well, it's
But-
the Maclaurin theory.
Odd ones.
Yeah, the odd ones is what we need to see, because the odd ones don't matter. So what you're going to do is create a power series that only incorporates the even numbers. So the series that you need to create on your own comes from the pattern that you see. So I see, so let's pretend the zeros are not even there. So the evens, right, is 1, negative 1, 1, negative 1, right? So I have an alternating piece, right? And I need to skip over the odds. So x minus pi over 2 to the even power, in other words, 2n. And I only want 2n factorial because I only want to see 0, 2, 4, 6. See that? Do you see how this will work? Or how we can create that. This section is difficult because it requires you to see the pattern on your own. So you guys see where this came from, right? Okay.